Hi everyone, welcome back. Looking at non-right angled triangles. We've looked previously at the sine, cosine and tan ratios for right angled triangles. Now let's look at non-right angled triangles. I can look at each of these corners and give them a name, and their names are usually in capitals. Most people put them in capitals. Capital A, capital B, capital C. Then if you go across from the capital A, we have what we call little a, or lowercase a. Across from B, capital B, you've got lowercase b, and across from the capital C, you've got little c. So it gives us a chance in the system. Capitals are for the corners or the angles, and lowercase is for the three sides. So here's your formula, not going into a proof of the formula, just looking at how can you use this formula to get the answer. By the way, if I wanted to, I could draw up a scale diagram of that. I could draw it up in reality, 55 degrees, go out 5 metres, go out 6 metres, and figure out how far it is across there. So the beauty of trigonometry is it saves us doing scale diagrams, and then it also means though that we have a much more accurate answer. Because if you get that angle out slightly, it's going to make your answer quite inaccurate, and we need much more accuracy than that. Let's put the numbers in, and the letters. That's an x, that replaces the c, so the c becomes an x, which is x squared. The A becomes a 5, which is 5 squared. The B becomes a 6, which is 6 squared. And then we've got minus 2 times whatever the A is, so there's a repeat of these. If you notice the pattern, there's A and B there, and there's A and B there. So that's 5 times 6, and you multiply by the cos of the angle, which is 55 degrees. What I want to draw to your attention though, is that the x and the 55, if you look here, the x and the 55 are opposite from each other. So this form of the equation and this question will only work if the x is opposite the 55 degrees. Later on we'll find the angle, and that'll be different because we need to know what that side is and we work out what the angle is. But if you want to work out the length of the side, we need to know what this angle is opposite it. If you look at the shape itself as well, we have information written on all three sides. So one of the indicators or the simple ways of checking which formula to use, if you've got information on all three and it's a non-right angle triangle, you know it's probably going to be the cosine rule. So then I can go to that formula. There is quick ways of doing it. If you're in Western Australia, we have a calculator called a ClassPad, and all I have to do on the ClassPad calculator is go to solve, put the bracket, and at the end press Xe, and it will tell us the answer to the question. The traps though are, you've got to watch out, we're in degrees. So there's three choices, there's degrees, there's radians and there's grads. Radians are for year 11 and 12 higher level maths, and when we're doing calculus as well, which is topics that come later on, we need the radians. This one G is for grads, which is the French system. There's 100 grads in a right angle. So instead of splitting a right angle into 90 like we do for degrees, they split it into 100. Australia considered it as a possibility and rejected it some years ago, but the calculators are made to take all the different circumstances in. Let's have a look at what we've got here. Let's say we didn't put it in the ClassPad and we only had scientific. Even here in Western Australia, even though the ClassPad is allowed, a lot of times teachers will restrict it to being just a scientific calculator. So I can write this as, if I want to get rid of a square, if I take the square root of this side, square and square roots are the opposites to each other, what I call opposites to both sides. So the opposite of square, you can see in the wording itself, is square root. So square and square root are opposites of each other, they cancel each other out. So if I want to cancel out the square, I take the square root of the left hand side, and it says the opposites to both sides. I have to take the square root of the right hand side. So I've got all of this written underneath that square root. The good part is you can just type it in your calculator. Just go from left to right. So you get 5 squared, then plus the 6 squared, and just keep typing it in. And when you're finished on most calculators, you can press equals. Some calculators like the ClassPad, you can press Xe, and it'll tell you the answer to the question, which I've already calculated here. And that's 5.1561, and if it was metres, and then I could say that was 4 decimal places because I rounded off to 4. Of course, your teacher might say they want it to be 1 decimal place or 2 decimal places. So let's say we did this one to 2 decimal places. I still worry about people with rounding off. A lot of people still struggle with it. Even, just silly mistakes that people make. I like the peekaboo method. It's almost like with children when you put your hands in front of your face and go boo. So I call it the peekaboo method. So if I looked at that 1.5, it's either going to be a 0.15 or a 0.16. So is it closer to 0.16 or is it closer to 0.15? So that 6, if I take my hand away, is it a big number or a small number? The definition of big and small, most people are okay. They look at it and go, well, 6 is big, so therefore it's going to round up. It's not going to stay as a 1.5, it's going to become a 1.6. So in other words, we're closer to 0.16 than we are to 0.15, so it rounds up. And that's metres to 2 decimal places. So briefly go back through it again. You've got 3 letters for the 3 sides, and they're in the lowercase. You've got the 3 capital letters for the 3 corners. But here, if I did the same question again, and I took off all the letters, let's have another look at it without the letters. Some people will look at this fairly quickly and go, oh, I can do this easily without going through all that. So let's have a look at the routine for going through that. Important, using this pair here is the most important pair. So that's going to be the first one and it's going to be the last one. If you had the formula written down, you can say, well, this is x squared, and then I've got the other 2 sides, not the ones opposite the angle that you've got, and that would be a 6 squared. You can go either way, it doesn't matter if you go 6 squared. A lot of people would go 6 squared is 36, 5 squared is 25, and then I've got 2 times 6 times 5, and it doesn't make any difference which way you multiply them, it makes no difference which way you do those. So we're really only looking at this pair. So that's your x squared, and then opposite that one there is the cos of 55 degrees. And then, like before, you put in your calculator, how do I get rid of a squared? I could write it this way, it might be helpful to some people. If I get the square root of this side, I get the square root of that side there. If you did want to shortcut your working out a little bit, there's really only one line of working out. And then you come to the answer, which again is 5.1561 metres if I went to 4 decimal places, and of course I could round off to less decimal places. So some people rely on the letters and like the letters to be there, some people don't. A bit annoying sometimes if we put completely different letters on there, like H and K and say J, and you're using those letters. For some people it's good for them to ignore the letters and say this is the important pair, and I've got that pair there, and then the others go in the other positions. I hope it helps.